Okay, so I hope you guys watched Journal 15, and so now what we're going to do is practice some problems from the homework packet. So let's do some homework and get that out of the way. So here's some problems from, I think this is packet 3, page 4 and 5. So I think this problem is on page 4. And so what we're going to be doing is, this one's about Casey. And Casey attempt to solve the system's equation. And so this is a 3 by 3 because we see 3 equations and 3 variables. And it says, like, can you find the error that Casey made? So it looks like Casey showed some work here and here. Maybe he paired up 2 here and then paired up another 2 here. And so let's go ahead and see if he made any mistakes here, because they said he did, but we need to figure out what kind of mistake he made. So first, when I have a 3 by 3 system, I like to label it by number so that way I know which equations I'm using. I need to figure out what equation Casey used, so that's why I'm numbering it. So looking at the first equation, that's just identical to the first one here that he wrote down. So this must be the first equation. And then the second equation, I think, is the second one here, right? So this bottom equation, I noticed that there's an 11 here. Well, there's an 11 here too. There's a z and a 2y, and there it is here. The only difference is that there is this 4 there instead of just a 1 as the coefficient. So this one must be the second equation. Now, because I noticed that there's a 4 here, and there wasn't a 4 there a moment ago, what I'm assuming is that they multiplied the second equation by a coefficient of 4, right? So they must be doing that in order to cancel out the first equation, x. So they're trying to cancel out the x's, so that's a -4, that's a +4. So those two would cancel. The only thing that didn't happen that Casey forgot to do you guys see it? Well, he forgot to multiply everything in the equation by 4, right? And I mean, when he didn't do that, I was it was so easy for me to recognize that this was the second equation because it looks almost the same. And so in this case, he forgot to multiply by 4. So I'm just going to say the entire second equation should be multiplied by 4, not just the x term. So he only multiplied it to the x, but he should have multiplied it to everything in that equation, the entire equation. So that's kind of what I've put out as my explanation. So all you got to do is really, I would say, identify where the mistake is. So I'm just going to circle where that mistake was and explain why. So let's go see what happened in the second one that he tried to pair up. So it looks like the first equation here, since I spot that -18, I think this equation is number 1. And the second equation looks identical to the third one here. So this bottom equation looks like the third one. And so looking at it, the first one looks a little bit different than what it originally was, right? The first equation here had a 4 instead of a 12. So it looks like they multiplied, well, how do you get to 4 to 12? You multiply by 3. Let me get my pen here. So we multiply by 3 to do it. But we have to multiply every term. So if I multiply the next one, the y by 3, I should get a -3. So they do have that. If I multiply 3 with 2, that should give me 6, and they do have a 6z. But -18 times 3 should have been -54. This should have been a -54, but it isn't. So that last number on the other side of the equal sign did not get multiplied. So that's the mistake here. And so I'm just going to write, again, the entire first equation should be multiplied by 3, not just one side. So something like that. This is a very common mistake that I actually made. Like, I'm very good at multiplying everything on one side, but sometimes I'll just forget that number, that constant that's sitting on the right-hand side. And so know that this is a very common mistake, and that's why I want to bring up these most common mistakes, so that way we can try to avoid them. So again, whenever you use a multiplier, you need to multiply the entire equation, not just one side, not just one variable. All right, let's go into some solving systems of equation problems, because I know that takes a bit longer. So we're going to turn to the next page, page 5, and we're going to start out with problem 4. All right, so this is problem 4 on page 5. So if you want to follow along with me. So in this problem, the first thing I will ever do when I'm solving a 3x3 is I am going to number it. Goodness sake, I can't say that more than enough. You must keep track of it by numbering your equations, because it does get messy, and it's going to be very hard for me to help you when you mess up if I don't see it numbered, because I don't know which equation you combine, which equation you got as your 4, your 5. So please number your equation. So looking at this here, we are going to pair up two equations to cancel out a variable. So first I'm going to just determine which variable I'm going to decide to cancel. Remember, opposite signs, let me write it up here. We can cancel when they are opposite signs and the same coefficient. So in this case here, maybe I want to cancel out, maybe the z's might be nice, because I can already tell that the z's 1 and 3 will cancel because both of their coefficients are 1. So I'm going to do z's, but it really doesn't matter. You could have chose any variable. But for convenience sake, I'm going to choose 1 and 3 first. So I'm going to pair up 1 and 3 so that I can make equation 4. Remember, when we cancel out a variable, we create, equation with two variables. So in this case, when I pair them up, I'm just going to rewrite the equation here. So equation 1 was 2x plus y minus z equals 9. And then we have 5x plus 7y plus z plus 4. And so when I add these two together, I already noticed that the z's should cancel, right? Because they're opposite signs, same coefficient. So now I'm just left with x's and y, so I'm going to combine them. So 2x plus 5x gives me 7x. 1y plus 7 is going to give me 8y. And then 9 plus 4 gives me 13. So this is going to be equation 4. So I'm going to keep that in mind. Now remember, we're going to build equation 5, which needs to have x's and y's too. When we try to solve for another variable. So in order to do that, we have to cancel out z's again when we pair up our second one. So I'm going to pick two equations that I'm going to pair up and then cancel out the z's. So when I look back here, I've already used 1 and 3, so I can't use them together again. So maybe I'll pair up 1 and 2, because what I notice is 1 and 2 are already opposite in signs, right? Like this one's a negative, this one's a positive. So all I have to do is maybe, like this is a 1 as a coefficient, so I need to make it a 2. So I can multiply by 2 here to make that happen. So I'm going to show you what I mean. So this is going to be equation 5 eventually. So I'm going to pair up 1 and 2 together. I'm just going to rewrite what their equation was originally. So when I pair them up here, what I'm going to do is I'm going to try to cancel out the z's. So I'm going to multiply the top here by 2, so that can be a negative 2z to cancel out with that z. So if I multiply, make sure you multiply to the entire thing. We don't want to be like Casey. So if we multiply by 2, we get 4x, 2y, 2z, and 2 times 9 gives you 18. The bottom here is negative x plus 6y plus 2z equals negative 17. And so if I add these together, then the z's cancel out. And so I'm going to combine the x's and y's. 4x plus negative x is going to give me 3x. plus 8y equals 1. 18 plus negative 17 is 1. And so this here is going to be my equation 5. Okay, this is looking good so far. So I got my equations here. The only thing I need to do next, since now I have my 2 variable equations, I'm going to take 4, I'm going to take 5, I'm going to stack them and make a 2 by 2 system so I can solve for a variable. So I'm going to make some room here. There we go. Oh, why did my 5 get left behind? That's so strange. Maybe can I pinch this? Oh, there we go. Sorry for this hold up. I don't know why it will not shrink. You know what? We'll just make 5 bigger. Okay, back to this. So I'm taking 4. I'm just going to write this in black. So I'm taking the equation 4, so that's 7x plus 8y equals 13. And I'm taking equation 5, which is 3x plus 8y equals 1. And I'm going to stack them like this, so that way I can, try to eliminate a variable. So what I notice immediately that is the y's are the same coefficients, right? Which is super nice because now all I got to do is make sure they're opposite signs. So maybe I'll make the bottom here and I'll multiply that by a -1. I got to make one of them negative, so I don't know. Choose the bottom. You can choose the top. Doesn't matter. But make sure you multiply the 1 into every term. So the top equation didn't get affected, so equation 4 will just come down the way it is. Equation 5, everything gets multiplied by a negative number, so everything just switches its sign. So if I combine these like terms here, I'm going to get, let's see, the y's cancel out. 7x minus 3 is going to give me 4x. 13 minus 1 is 12, and so if I want to get this x by itself, all I gotta do is divide by 4. So notice how, like, when I cancel out another variable, I'm now down to 1 variable, which is awesome. So if I divide by 4, x is going to be 12 divided by 4, which is 3. So I got x equals 3, which is great. Now that I have one variable, what I need to do is try to find the second one. So to find the second one, you don't want to go back to the 3 originals. You want to start going slowly backwards. So you want to go to either equation 4 or 5, so one of these, and plug your x value in so that way you can find the y value, the other variable that's in the equation. So what I'm going to do is plug it into equation 5. It really doesn't matter, but I just chose that one because the numbers are smaller. So I know what x is. X is 3 plus 8y equals 1. So I've plugged in my 3 into this equation. I'm going to work this out. So 3 times 3 is 9 plus 8y equals 1. If I subtract by 9, that cancels. So I have 8y equals -8. 1 plus -9 is -8. And then if I divide by 8, y is equal to -1. And so in this case, I have my x, I have my y, I need to go find z. So now, because I have 2 variables, I can use one of the originals. So I'm going to just choose the first equation. It doesn't matter which one you choose. So let's plug it all in. So in this case, I'm going to be plugging this into the first equation. So the first equation is 2x plus y minus z equals 9. And so if I plug in my x, which was 3, I plug in my y, which was -1, and my z is missing here. If I work this out from left to right, 2 times 3 gives you 6. -1 minus z. Well, you can combine these two like terms. So these two are the same, right? They're both numbers. 6 minus 1 is going to give you 5 minus z. Well, if you want to get this by itself, you might need to subtract over 5. Oops, sorry, that's a highlighter. That cancels. So then I have -z equals 4. 9 minus 5 is 4. If I divide by negative 1, z here is negative 4. So I have my z, I have my x, I have my y. I can write this as a 3 coordinate system, which is 3 for x, negative 1 for y, negative 4 for z, and there's only one solution because there's only one coordinate here. So let me just go over what's happening here when you're doing elimination with the 3 by 3. So you're pairing up 2, and then you're pairing up another 2. So when you get these new equation 4 and 5, what you've done is you've already eliminated one variable. So now you're down to 2 variables, right? Well, then when you stack up your 4 and 5, you eliminate another variable and you're down to 1 variable. When you get down to 1 variable, you can solve for that equation and get an actual value for that variable. Then you slowly back yourself up and plug that number in to find the other missing variable. And then slowly, you will get back to getting back to the original equation, and then you can plug in all your numbers, your 2 variables, to get your last variable. And that's it. Okay, let's do another one of these. I'm going to do it with number 5. Okay, so here's number 5. I will say, because the numbers here, you can already tell they're a little bit larger than what we're used to. So keep in mind, we are going to be handling larger numbers, so this one gets a little bit messy, but that's why we're doing it together. So first off, I always say to number your equations. So we're going to go ahead and do that so that way we don't get confused. And then the next thing is I want to figure out what variable I want to cancel. And so maybe something that has opposite signs and the same coefficients, right? So what I already noticed is that like the x's here, these two x's already have the same coefficients. And this one's a negative and the other two are positive, so that kind of gives me some opposite signs here. So I think I'm going to go with the x's, but you could have went with something else. You just need to make sure that the variables end up canceling. So whether you need to multiply something in to make that happen, you do you. So for me, I'm going to just use the x's because it seems like the easiest route, because if I pair up 1 and 2, right? They already cancel out the x's. So what I'm going to do on here, I'm going to rewrite. I'm going to copy the 1, copy the 2, paste them here. So this is going to be 3x plus 2y minus z equals negative 8. And negative x plus 4y plus 5z equals negative 14. And so when I add these two together, the x's cancel. And if I add up the y's, I get 2 plus 4, which is 6y. Negative 1 plus 5, which is 4z. And 8 plus negative 14 is negative 6. And so when I look at this here, I have my fourth equation. Almost forgot. This is going to be my fourth equation when I pair them up. So this is equation 4, and notice it just has y's and z's. So that means that when I pair up my next two equations, I need to make sure it has y's and z's. So I'm going to also cancel out x to do that. So when I look at this space here, maybe something that already has opposite signs, like 2 and 3 already are opposite signs, right? If I want to try to cancel out with the third equation with the second equation, maybe I need to make this x3. So I can always multiply by 3 to make that happen. So I think I'm going to go with pairing up 2 and 3 and calling that equation 5. So I'm going to write 2 and 3 here. And so when I write this, I'm now going to multiply my equation for the bottom one in order to cancel out the x's by 3. If I do that, well, make sure you multiply everything by 3, but the top equation, equation 2, doesn't get affected. So I'm just going to bring that down the way it is. Okay, so now our third equation here, let me erase that because I don't think I did that correctly. So the third equation would be, if I multiply by 3, 3x minus 3 times 3 gives you 9y, plus 3 times 4 is 12z. 3 times negative 14, you might want to get out your calculator for this part, it's going to be negative 42. And so if I add up these here, the x's are going to cancel because I made them that way. And then you have negative 5y, because 4 plus negative 9 is negative 5y. And then plus 17z equals negative 56. Negative 14 added with negative 42 gives you negative 56. So this here is our fifth equation. So remember, what we try to do is take our fourth equation and fifth equation and stack them, because then you can create a 2 by 2 to solve for one of the variables. So we're going to go ahead and set that up here. I'm just going to use black. So we have negative 5y plus 17z equals negative 56. So when I add these two equations together, I have to figure out what variable I want to cancel. And I don't think in this case there's one that's more favorable, because I'm going to have to multiply a number into the first equation and the second equation. Because 6 and 5, well, 6 and 5 can't beat each other. Neither can 4 and 17. So in this case, 6 and 5 can both be 30. We know that if we multiply by, the opposite number. So for the top one here, I'm going to multiply this one by 5 and the bottom one by 6. Now, the nice part is that one of them is already negative, so I don't have to worry about the signs. And now what I'm going to do is multiply the 5 and 6 through and see what my new equation is going to be once I cancel. So let me shrink this down just a bit. Okay, so for equation 4, we would have, that would be 30y plus 20z equals negative 30. And then we would have, for equation 5, negative 30y plus 17 times 6 is 102z. And 6 times negative 56 is negative 336. Okay, so what I'm going to do is combine these. Okay, so let's finish up this problem. I just shrunk it down so that way I have more room. So if I add these two equations, the y's cancel out. So 20 plus 102 gives me 122z. And then negative 30 plus negative 336 is negative 366. If I divide by 122, that cancels, and z is equal to negative 3. Negative 366 divided by 112 is actually negative 3. So now this is back to smaller numbers, which is kind of nice. So z here is just negative 3. And so if I want to go find the next variable, I have to go plug it back in to 4 or 5. So I'm just going to choose 4, maybe because it has less negatives. I don't know. That's just me. So if I plug in an equation 4, I'm going to be solving for y because I only know what z is. So if I work this out, 4 times negative 3 is negative 12. If I add 12 to both sides, you have 4y equals 6. Did I do that right? Oh, hang on, I wrote my equation wrong. Oops. This should have been 6 here. Right? Because there's a 6 here, 6y, 6y. I must have been looking at this 4 and got confused. Let me make sure everything else looks good. Yeah. Okay. So this should have been 4y. 6y. And then if I divide by 6 to get rid of the 6, I have y equals 1. So 6 divided by 6 is just 1. And so now that I have my two variables, I can go ahead and plug these two into one of the original equations. So I'll do that up here. Or actually, can I do it here? maybe. So for the first equation is 3x plus 2y minus 7z equals 8. Let's see if I can shrink this. There we go. That looks better. So if I were to plug the z in and the y in, let's see what we got. So it looks like I don't know what x is yet, but I'm about to find out. So 3x comes down, 2 times y, which is 1, negative z is negative 3. So if I work this out, this is 3x plus 2 plus 3 equals 8. These two are like terms, right? So that combines to make 5 equals 8. Well, if I subtract 5, that cancels. So we have 3x equals 8 minus 5 is 3. Divide by 3, x is equal to 1. Whew, okay. So that tells me that our coordinate here is going to be 1 for y, and negative 3 for z, so we have one solution. All right, guys, that's that's 3 homework problems from the packet. So please use this wisely, and I hope you learned a lot. Okay, until next time.